skill. 2, un. Skill, 2, un. 1, un.
No.
In German. Come on. Un. Get to the chopper. Skill 2-1 is over what? Through, is that what you're going to say? Ordering and comparing real numbers. What are real numbers? Real numbers. Come on now, what did we say yesterday? What are real numbers?
Aren't they like all numbers except like the fractions and stuff like that, like decimals?
Close. But fractions and decimals are real numbers. It's the largest set of numbers. Okay, remember our circle we did?
Yeah.
What was real on the outside or on the inside?
Outside.
Outside. So that means everything on the inside, that is a real number. Okay? If you're not real, then you are imaginary. Remember my friend Bobo, the dolphin? With the eye patch? Sphinx monkey. So, real numbers is the set of numbers that we're going to be using a lot in algebra. We will be working with imaginary numbers, but we're going to focus on real numbers. Okay? And those range from irrational to rational to integers. What are integers again? Who is in the set of integers? Bailey? Negative or positive whole numbers and 0. Those are the integers, okay? You guys work with integers more than probably any other set of numbers. Okay? Good. So, the example we finished up on yesterday is we had to graph the numbers. Okay? We had to graph, what was it? -6, 2,
It's actually
4,
plot the numbers.
-1/4, 5, are those the numbers? They may not be in the order, but. Okay. So, how do we graph those? On a what? On a what?
Number line?
On a number line, thank you. I'm losing my hearing, sorry. So, there's my number line. What's another word for a number line? It's up there. I'm bored already. A graph. Okay, that's a one-dimensional graph. Okay? What do we need to have for this graph?
The origin.
The origin. Why do we need the origin for this case? Because there's negative and positives, and the origin separates that. Very good. What else do I need? Starts with an S, ends with a K.
Scale.
Scale. Okay? I'm going to go this way. Maybe 6. Good. So now that I have my graph, I do what to graph those numbers? What represents these numbers on this graph? Points. Okay, points. And when you put a point on it, you're Plotting. Good. Plotting the point. So, -6, boom. I plot the point. -6. 2.4, it falls between positive or negative? Positive. About halfway. There's where 2.4 is. Good. -1/4. 0, -1, closer to. And then the number 5, which is exactly on that dash. Sweet. So we can plot points on our one-dimensional graph. Fantastic. Okay? Well, have we done any of that? No? No? Okay. So, let us do this. We're going to compare the following. Compare the following. Okay, up to bat first. We have 2.4 and 5. What does it mean to compare? Luke, what do you think? What does it mean to compare? Well, look at it. Think about it. Take some time to digest it. Let it run through that brain and intestine in your head. What do you think it means to compare? Well, when you're asked to compare something, compare a banana versus an apple, what would you say? What are some different things you would say?
Color.
What?
Color.
Okay, that's one thing you could compare. What else could you compare? Between an apple and banana?
Shape.
Shape?
Size.
Size. So, what do you think we're going to compare for these values? What are we going to be comparing? Are we going to be comparing either color?
No.
No. Are we going to be comparing their shape? So what do you think we're going to compare, Jordan? Size! Woo! Yes! Size. Well, how do we compare their size? Do I just say, nah, 5 is bigger, nah, 5 is smaller, nah, 2.4 is bigger? How do you show that? Do we just write a sentence? Kendra? An equality symbol, right? That shows who's bigger than who. Alligator mouth, right? So what do you think?
5 is bigger.
What?
5 is bigger.
So how would I, what would I put up there then?
5 is greater than
5
4 is less than.
Oh, yeah.
Good. Read it from left to right. Read it from left to right. Okay? 2.4 is less than, I'm going to get this out of the way now. That looks like less than me. 2.4 is less than 5. Well, why? How is that? Are we sure?
Yeah.
Why? Give me some evidence.
If you look at a scale right there, 2.4 is closer.
Say what?
Because 2.4 is closer to 0.
So 2.4 is closer to 0, so therefore it's smaller. Okay. All right. 2.4 is closer to 0, so therefore it's smaller. Let's try this one.
No, not always.
So, according to that statement, if 1/4 is less than 6, -6?
No.
Yes.
No.
Yes. She said when you're closer to 0, you're smaller than the other number. Only when you're in the positive numbers. So I have to have two ideas. I have to have an idea for positive numbers, and I have to have an idea for negative numbers. That's ridiculous.
Wait. Isn't it like...
No, I don't. That's too much.
No, can I explain something to you?
Oh my gosh, you guys make me.
Can it be if you're like closer to, the more you go left on the scale, the smaller the number gets?
She's right. The further you are to the left, okay? Smaller. Further to the right, you're bigger. Okay? Tanner, come up here. Logan, come up here. Luke, come up here. Will, come up here. Logan, go to the left, right there. Will, right here. Luke, right here. Tanner, right here. Who is the smallest?
What?
Who is the smallest?
Logan.
Why?
Because he's farther to the left.
He's farther to the left. Logan, if these four gentlemen were on the number line, Logan would be the smallest, Will would be the second smallest, Luke would be the second biggest, and Tanner is the hugest. Right? Isn't that what we're saying with this number line?
Yep.
Okay, gentlemen, thank you for participating. So Logan is the smallest person in here. Okay? It's okay. We still love it. Alright? Good. We got the right idea. So can you guys compare numbers? And can you give me an explanation why? Yes, I know you probably guys compared numbers in middle school and in 6th grade. And isn't 6th grade in middle school?
Yeah.
No.
I went to
Well,
a,
it wasn't that.
I went to a junior high. It was 7th and 8th grade only. So it's kind of
We
weird.
ran out. We had
We have that
You have that now?
now.
Anyways, we're getting off discussion. Okay. So now we're taking it one step further. You're going to be now to be able to explain it. Give me a reason why we can compare it. So now you just can't go, this is bigger than this. You have to say, this is bigger than this because. Why? It's further to the left.
But it's on every single one.
You bet. That's a great little thing. Air quotes. No. After you write it once, you write it.
So we can do that?
I don't, yeah, that's fine.
Wait, just little air quotes and then.
Ditto marks, is that what they call them? Ditto marks, yeah. Okay.
It's like repeating.
So, good. Or, how, okay, change my mind. Instead of writing a sentence, I want you to show me the word. So what do you have to make?
Stupid number line.
It's not stupid, it has feelings. You're not hurting its feelings. Okay, good. Next example.
Do I get extra credit or something?
Alright, now,
Come on, Iowa. It's just on my shorts.
write the,
Why should?
because I want it to be, thank you for caring.
And then your age is
They clapping over there?
for us.
We're
so awesome.
Because we are so awesome. Alright, write the numbers in increasing order.
What numbers?
Those numbers. So what is, the ones even more Chico? So, what does it mean to be increasing order?
They're increasing in value.
Okay?
From smallest to biggest.
You're writing the smallest number, then the second smallest, then the third smallest, all the way up to the biggest. So if I were to use our example from earlier, There we go. Logan will Luke and
Lord.
Lord of the Rings.
Wow.
I
Okay?
don't even take this big college, I'm guessing.
Say what?
Taking Lord of the Rings.
Are you?
Oh, yeah.
Aren't you proud?
No.
Yeah, you should be.
No.
Okay? So, are we good there? Pretty simple. Comparing and ordering. Any questions? Yes.
Yeah, just like right up the left, right, and
Pretty much. Isn't that what you're doing? If you're writing a number in increasing order, after you've plotted them on the graph, aren't you just going like that? What if you're writing them in decreasing order? Right to left. Good. Question? Alright. So that's comparing and ordering. What do we haven't talked about yet that you guys read about yesterday?
A lot.
Like what?
opposite.
Absolute value?
Opposites and absolute value. That is correct.
Yeah.
So opposite. What's it mean?
Not the same as the other thing.
Not the same as the other thing. Okay? A little more to that. Opposite. What'd you guys put down for your definition?
So the 5 is negative 5.
So you put an example. Is that what you're saying is true?
Yep.
What else did you guys have for definitions?
Points that are the same distance from the origin, but on opposite sides of the graph.
Good. Points. So what's the theme we've been using to show these? Number line, the graph. Okay? So opposites are the same distance from the origin. They're just on the different side of the origin. Okay? So that's all there is to it. The symbol for opposite is that guy. Who is that guy?
Negative.
A negative. Okay? So if I wanted the opposite of 4, what would it be?
Negative 4.
Negative 4. If I wanted the opposite of negative 6, what would it be?
Maybe 6.
It'd be 6, because this means the opposite of negative 6. Okay? The opposite of negative 6. Pretty simple. Anytime you see this guy, what does it mean?
Opposite.
Okay? So what if we had this? Try this guy on for size.
Holy.
Wait, what?
Stop it.
Yeah. 5.
Negative 5.
What is the opposite of the opposite of the opposite of the opposite of negative 5?
5.
Five?
Negative.
5.
It's
Wow.
It's 5.
How do we work? How would we evaluate this? What would we use? What is this? What do we call this right here?
A really big easy.
No, when you have a mathematical statement, you have 3 choices. You have an inequality, an expression, or an equation. What is this? An expression. How do we evaluate expressions? Order of operations. What comes first? Will and order of operations. So where do we begin? On the outside or on the inside? The inside. So the opposite of negative 5.
5.
Okay, so this guy's gone. The opposite of 5.
Negative 5.
The opposite of negative 5. The opposite of 5.
Negative 5.
So the opposite of the opposite of the opposite of the opposite of negative 5 is negative 5. Makes sense?
Yeah.
Okay, good. So we're clear with opposites? What's the opposite of x? Negative x? Negative x. Okay, whatever x is,
Yeah.
it's the opposite. Okay? Good. Absolute value. Have you guys heard of of absolute value report?
B.
C, singular. What's the definition? What's your definition? Not the book's definition. What's your definition? What have you guys always been told? When you guys saw the absolute value, you saw the absolute value of -3. What was your final answer?
3.
3. Why? What does the absolute value sign do? What does it mean?
They changed that.
It changed it, so it's opposites?
So it's positive.
It's always positive?
Yeah.
So the absolute value, man, it says it just changes everything to positive. Okay, the correct definition for absolute value is the distance from the origin. The distance from the origin. That is the true, dead-on definition. Now let's think about this. Look at that definition. The distance from the origin. Why? Why is everything positive? Really? Distance, right? Boom. I traveled this far. I went 3 feet. My distance was 3 feet. Wasn't my distance now -3 feet? Yeah. It's 3 feet. Can you ever have a negative distance? No, it's not possible. So that's why the absolute value, every value you get should be positive. Positive. Okay? Does that make sense? Alright, well, let's evaluate this sucker. Come here, sucker face. Here we go.
Are those brackets or those ones?
This right here, these are absolute value lines. So what's it going to be? Can you tell me right now what it's going to be? No. You evaluate that. What's it going to be? Raise your hand if you think it's 6. Raise your hand if you think it's -6. Oh. I'll give you more time.
Oh, okay, that's.
Okay, got it.
Those aren't ones.
No.
No. These are absolute value symbols. Absolute value parentheses, absolute value. So you ready to try this again? +6, raise your hand. Raise it high. If you think it's a +6. Raise your hand if you think it's a -6. Where do you begin?
Inside.
Inside. What is it? So the inside right now is the absolute value of -6.
Right.
What is absolute value again? 6. What does the absolute value mean?
Oh.
The distance from the origin. So how far is -6 away from 0? 6. So now I have 6 here in parentheses, an absolute value. Oops. What's the opposite of 6?
6.
-6. So I'm moving right here. -6 and absolute value signs there. What's the absolute value of -6?
6.
Aha. What's the opposite of 6? So our answer is. Alright. So the big thing is work inside, weed your way out. Okay? Capiche?
Yeah.
I'm going to let you know, on the homework assignment, there's going to be some mental math problems. And I want to see if you guys can do them on your own.
Yeah.
Okay? Capiche? numbers 18 through 53.
What page?
67. Numbers 18 through 53. Five threes.
What does that mean? So you go for
Every three problems.
Oh yeah, just making sure.
So you start off at 18, you skip 19, you skip 20, 21.
There you go.
Then after that, you skip who? 22 and 23.
Yep.
Then you do